Okay, let's go over problem number 1. So we have 1a, n squared is equal to omega n square root of n. So it says to use limits to show that the following statements are true. So limit as n approaches infinity. It's going to be the numerator, which is the left side of the equation, over denominator over, which is inside the parentheses. So it's going to be n squared over n square root of n. We can simplify this to n over square root of n because of this. And then we can simplify this further by bringing the denominator to the numerator by doing it to the power of negative 1/2. So n subtract n to the negative 1/2. And then to simplify this further, we just subtract. So this is going to be 1 over 1, and 1 over 1 subtract 1 over 2 is equal to 2 over 2 subtract 1 over 2, which is just going to be n to the 1/2. And that's our fully simplified version. So I guess a way to prove it is to draw a graph. So if we were to draw an x and y coordinate plane and have t-chart and plug in values. So let's do 0, 1, 2, and 3. So 0 to the 1/2 should be 0. Yep. And then we have 1 to the 1/2, which is 1, and we have 2 to the 1/2, which is 1.4, around there. And then we have 3 to the 1/2, which is 1.7, around there as well. And let's add a 4. Oh, and then we get, it should be 2. Yep, 2. So now let's plot it. So 0, let me use a different color. 2, 3, 4. 1, 2, 3, 4. Actually, sorry. Let me move this real quick. So 1, 2, 3, 4. 2, 3. 1, 2, 3. So we have 0, 0, 1, 1, 2, and then it's 1.4, which is around here somewhere. 3, 1.7, somewhere around here, and 4 and 2. So we could just draw this. And from this we can tell that as x approaches infinity, so does y. Because it's going up. So this proves that statement, which is equal to infinity. Oh, I forgot to mention that here's a little like cheat sheet. So this sign is omega. Let's see. Omega, which is equal to infinity. This sign is 0, which is just 0. And then this sign is theta, which is equal to constant in this scenario, which is like a whole number, like 1, 2, 3. And so when we're looking at this statement, we're trying to say that as n approaches infinity, so does y. Okay. Let's do 1b. I'm going to move this. We have 2n is equal to 0, 3n. So here's the limit as n approaches infinity. It's always going to be n approaches infinity for this. It's going to be 2n over 3n. We can simplify this by taking the n out. And this is the finalized simplified version, and this should equal 0 according to the statement. So we can prove it with another graph. Zero, 1, 2, 3. Let me plug it into my calculator. I think the first one's just 0. Oh, it's 1. And then this is just 2 over 3, which is equal to 0.66. And then this one is 4 over 9, which is 0.44. And then this one is 8 over 27, which is about 0.296. And I think that should be enough values to work with. 1, 2, 2, 3. So we have 0, 1, and then we have 1, 0.66, which is maybe over here, 2, 0.44, and then a really small number. So if we draw this, let me move this up. Sorry, give me one moment. Okay, so if we draw the, it should be going downwards. I know it looks very like linear, but it's not. I can add another value. Let's see. That's 0.19. Or I think it's better to do like a -1 maybe. Show it better. -1 is 1.5. So 1.5. I mean, okay, that somehow made it worse, but just know it's not linear. So what we can tell from this graph is that actually, it would look a lot better if I added this one as well. 0.19, which is somewhere here. There we go. Okay. As x approaches infinity, y is approaching 0 because it's going down, but it never really touches 0, and it's approaching it, so that's how we know. And that kind of just proves this statement here. And also, because 2 over 3 is less than 1, it's gonna be a 0 here. So now we can work on 1c. So we have 3, 2 to the nth is equal to 0, 2, 3 to the nth. There's like parentheses around it, but it doesn't really matter. Limit. And then 3, 2 to the nth over 2, 3 to the nth. We can simplify this by taking the natural log of it. So when we do the natural log, which is ln, we take the exponent and we move it forward, and then we take this number and we put it inside of the ln. We're going to subtract this. 3n ln 2. And you know, by looking at this, you can tell that since this number is bigger than this number, -3 is going to be more dominant, which means that it grows faster and the graph is going to be negative. Like it's going to go towards the negative part of the graph. So we can simplify this further as well, especially in the study guide. It says hint, use the result of part B. And in part B, we figured out that 2/3 to the nth is equal to 0. And if we look at our numbers, we have kind of the same numbers. So we're going to be able to just take this 3 out, 3n to the nth out, and this becomes 2 to the nth over 3 to the nth ln 3 subtract ln 2. And we could simplify this further by just doing 2 to 3 to the nth ln 3 minus ln 2. And now it looks identical to this one. So what we can do now is plug that in, plug the 0 in. So 0 times ln 3 is just 0, so you can just subtract ln 2. And this also becomes 3n negative ln 2. So this is as simplified as we can get it now. We can write the limit n to infinity, but actually we have to get rid of the ln, and to get rid of it we have to take the exponential of it, which is e. So now that we have this, let's plug in some numbers to this. So if we have 3 to the, let's say 5 ln 2, that gives us -168. Let's take a bigger number. Let's do 3 to the 100th. Now that gives us -3, approximately -3.57 times 10 to the 47. So that's a huge number. And so what we can just assume is that as x approaches infinity, y is approaching negative infinity. So what we could do is just replace this with e to the negative infinity because we know it's going downwards. So now we have limit as n approaches infinity equal, e to the power of negative infinity. And by definition, e to the power of negative infinity is going to equal 0. If e was to the power of just positive infinity, that would just equal infinity. And so if we look at our answer, that proves this statement here. So now we can go over 1D. Let me rewrite that. So if h of n is equal to 0, f of n, then f of n plus h of n equals theta f of n. So we finally got a constant question. No numbers, but our equation is going to be this. This is just like a if. So we can write our limit here as n approaches infinity. So remember, everything on the left is our numerator. So f of n plus h of n over f of n. Well, we can actually divide this. So if we were to expand it, so if we had f of n over f of n plus h of n over f of n. So this is the same thing as the same thing as this. So when we divide this, that becomes 1 plus h of n over f of n. Okay, well, now we can use that definition where h of n is equal to 0 to multiplied by f of n. So if we were to, I'm going to write it down here. So it's 1 plus h of n over f of n. So h of n, 0, f of n over f of n. Now we can just get rid of that, and this becomes 1 plus 0 equals 1. And that just proves, this number just proves that this is correct. Because remember, in our little like cheat sheet here, oh, did I erase it? Oh, it's over here. That's a constant.